Hello everyone, welcome to Aptitude course. So before going to the course, let me explain about myself. So myself KV Ramana, and I graduated from National Institute of Advanced Manufacturing Technology, previously known as NIFFT. It was located in Ranchi, National Institute of Foundry Forge Technology. And I qualified 4 times in GATE examination, that is graduate aptitude test in engineering. They will test aptitude in engineering exam, so engineering field. I had 3 years experience in industrial as well as more than 4 years experience in teaching, and I wrote several recruitment exam, state level and central level, and more than 200 plus examinations I wrote. Now I am currently working in IIT Madras as a technical staff. So along with that, I just finished foundational course, BSc Data Science online degree program, which was launched by IIT Madras in 2020. Now I'm currently a diploma student in the programming certification in that same degree program, and I got opportunity in ISRO. So now coming to the aptitude course, so it was very important one. If you see that importance of aptitude in any recruitment exam, private as well government sector, they will not conduct any examination without aptitude test. So everywhere the aptitude needs, and they will test the aptitude. So what is aptitude actually? So in this course we will learn what is the meaning of aptitude and why it is important, what is the need in our daily life as well as our professional life, what are the different number systems are there, and so in detail about decimal number system, why this decimal number system, currently we are using this decimal number system. Okay, let me change ink color. Okay, so now coming to the aptitude, it is an excellent method to determine person degree of intelligence. So what is mean actually? It's a sense of humor or common sense, how the person is using his thinking level. So simply we can call it as intelligent. If the person is more intelligent, he has the more aptitude. So simply we can determine based on the intelligence, he has more aptitude. Aptitude means it's simply intelligent, and it's play important role daily life as well as professional life. We already talked about that. Daily life also aptitude is needed. For example, the applications of market. Whenever you are going to the market, you have to optimize yourself based on the money and what you needs, and the stock markets and banking sector, and any sector. If you see the traveling or lot of businesses, also aptitude is needed. So generally aptitude test it enables to the recruiter to gauge how well can carry out the task. So any work, how can he do, how we will do, how much efficiently he can do. So that will gives the some judgment based on the aptitude test. Now it is a lot of names were there in the aptitude. We can call it as a quantitative aptitude, we can call it as a numerical aptitude. So numerical means we are dealing only with the numbers, and arithmetic and general aptitude and mental ability and elementary mathematics. So mostly in that course we are dealing with the numerical aptitude. There were another two categories, verbal aptitude and non-verbal aptitude. So the verbal aptitude means it's a words and letters. So whatever the aptitude, we are dealing with the words and letters, and that is the verbal aptitude. And non-verbal aptitude, it was dealing with the symbols. So a lot of different symbols they will give, and we have to choose correct one in the multiple choice questions. So these two types of aptitudes we are not going to discuss in this course. We are always focusing in this course numerical aptitude only. So let us coming to the what is the numerical aptitude. So mostly numerical aptitude we are dealing with the numbers, and number has the some specific mathematical value which is used for counting and measuring and label objects. and we can use the arithmetic operations between the numbers. So for example, if you make it as a 2 plus 4 is equal to 6, so you are doing the addition operation in between the 2 and 4, you will get the result is 6. So now coming to the different number systems are there. There is a four mainly number systems where exist. So decimal number system and binary number system and hexadecimal number system and octal number system. How these names were came based on the base. They have the specific number. Base is 10 in the decimal number system, binary number system 2, and hexadecimal number system 16, and octa number system base is 8. How this base and why it is important in base, we are discussing later. So deci means simply we can saying it is 10. If you see the deca and deci, so deci means 10 to the power of minus 1, and deca means it's a 10 to the power of plus 1. Now coming to the binary, so whenever it is called it as bi, it indicates 2. There is a binary system and there is a bilanguageal, that means 2 languages. Bi-weekly, it is a weekly 2 times. So now coming to the hexadecimal, hexa means it's a 6 and decimal means again it is 10, so 6 plus 10 is equal to 16. Octa number it is 8. We know well, pentagon, hexagon. Pentagon means it's a 5 sides, and hexagon is 6, heptagon is 7, and octagon is 8, and nonagon is 9. So based on the numbers they were putting as names for the different number systems. Now coming to the what is the importance of base. Now we just going to the decimal number system. So in the decimal number system, base is 10. What is the importance of this base, how this came? So whatever the numbers or numerals we are using in that particular number system, that is called it as a simply base. Now so in the decimal number system, it is the usual number system we are using. So mostly more than 90% in the world we are using this decimal number system only. Now so what are the numerals we are using? Simply we are using from 0 to 9, 0, 1, 2, 3 and 4, 5, 6 and 7, 8, 9. So these are the numerals. Now how many numerals are there? So 10. So that is the reason the base of the decimal number system is 10. So because of the 10 they put it as a name is a decimal number system. Now what is the basic procedure, what is the basic concept behind that any number system, behind the numbers, how can we call it as a numbers? For example, if I take this current year 2024, we can call it as a 2024. Why it is 2024? There is a concept. So before going to that, just explain face value and place value. So place value and place value. So place value means it's a simply mathematical or value of the number. So value of the particular number, and place value is it depends upon position, where the number from the right side, how many places where it is. So depends upon the position, and we can call it as place value is equal to positional value into face value. Okay, now can you tell anybody what is the face value of 2? Face value of this 2 is 2. Face value is 4. The face value will not change irrespective of the place, but place value it will change irrespective of respected to place. See, this 2 is the from right side, if you can call it as it is the second position. This 2 is the fourth position. So this 2 is in the 10th place, and this 2 is the thousands place. How this 10th and thousands came? Simply, if you want to know the basic concept, simply write 0, 1, 2, 3, 4 so on from the right to left. You are starting to rightmost hand, and you will go to numbers, keep on increasing the numbers to the left side. Now if we make it as the take it as a base and make it the power of these numbers which are you are already written. So 10 to the power of 0 is equal to 1. So that means it is the unit place is here, this is the 1. So we can call it as this is the positional value. So where this 4 is there, in which place it is there, which position it is there, 1th place. Now coming to the 10 to the power of 1, it is the 10th place. 10 to the power of 2, it is the 100th place. 10 to the power of 3, it is the 1000th place. So that means this 2 is in the 1000th place, this 2 is in the 10th place. Now how the place value will come? Simply multiply the positional value into face value. So this positional value is 1000, so the 2 is in the 1000th place. 2 into 1000, that is the 2000, and 100 into 0, that face value is nil. So that is the reason place value is equal to 0, because face value into position value is equal to place value. So this 2 into 10, that is the 10th place, 20, and this 4 into 1, this is the 4. Now if you add all these things, you will get the 2024. That is the reason we are calling as this 2024 2024. For example, if 898, that is the Kalki, how can it is call it as 2000, because 2 is the 1000th place, 800, 8 is the 100th place, 90, 9 is the 10th place, 8 is the 8. So that is the reason we are calling as a 2898. So this is the basic concept behind the any number system. First you have to choose the how many numerals are there, that is call it as a base, and make it as a right number, and we can simply get the what is the value of this 2024 value of any number system. So let us coming to the binary number system, and we know that bi means it's a 2, only here it is in this number system 0 and 1. So whatever the number you are writing, you are always using these digits only, because in this system only two digits are existed. In this system 2 digits only they are using. Now what is the importance of 0 and 1 in this binary number system or hexadecimal number system? Mostly using in the computers, the application is computing. Okay, so how this computing, mostly the computers was made from the electronics, if you say specifically transistors. This 0 is called it as off condition and on condition of a transistor. What is off and on? If the electricity is there, electricity, based on the electricity in the resistor transistor, if electricity is there, then we can call it as a 1. If electricity is not there, it is 0. Simply it is the 0 and 1 on and off condition. So that means computer knows only on and off condition, that means 0 and 1 value, that knows the electronics device or the electronics specifically some device transistor has the electricity or not, is there electricity or not, that's the only. Now coming to the, if I write it as a 1011, now if you see the decimal number system, this is the 1011, but specifically I will make it as a 2. So this indication will that this is the not a decimal number, it is the binary number. So simply base is the 2. So I just make it as this 2024 as also 10. Usually we are not writing as a in bracket it is 10, because we know that we are all are using in the decimal number system, but specifically here we are discussing the 4 number system, so that's why we are indicating the special number after the brackets. So now this is the 1011 is the binary number. Now what is the value of this binary number? We can simply follow the basic rule, just write down the 0, 1, 2 and 3, and go to the 2 to the power of 0. Anything for 0 is 1, and 2 to the power of 1 is equal to 2, 2 to the power of 2 is equal to 4, and 2 to the power of 3 is equal to 8. Now these are the positional values. Now what is the place value? Simply face value into positional values. What is the face value? Here face value either 1 or 0. If it is 0 and it is just place value is 0, because nil, face value into positional value. So 8 into 1, that is 8, and 4 into 0, that is 0, 2 into 1, that is 2, and 1 into 1, that is 1. Now if we add all these 8 plus 0 plus 2 plus 1, you will get the 8. So that means the value of a binary number 1011 is equal to 11 in the usual notation or usual number system, that is decimal number system. Okay, now can we convert any decimal number into binary number? Yes, we can. For example, if I take the 156 of the decimal number, usual notation I can make it as a 10 decimal number. Now what this 156 indicated in the binary number, how can I indicate? So you need same procedure. Just before going to that, just write down the 0 to 1 numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8. Now make it as a positional values. 2 to the power of 0 it is the 1, 2 to the power of 1 it is 2, 2 to the power of 4 4, 2 to the power of 2 is 4, 8, 16, 32, 64, 128 and a 256. I know that up to 8th position, that means 9th place. If you are seeing as a 1 2 3, 8 is the 9th place, it is the 256. Now I can stop it here. Why? Because I need this number 156 have to convert it into the binary number, but 156 is the larger than the 256 is the larger than the 156. So I will not go to the this 9th place. I can simply go to the these 8 numbers, because the 256 is not necessary. Now we can say before conversion, I can say this number should be as the 8 length of number is 8 numerals will come. So what is the length of this number 156 in the binary system? Definitely it will come 8 places. Why? Because that 9th place of 256 is greater than the 156. Now simply 128 is less than the 156, so I will write it as 1. If I write it as 1 here, what is the place value here? 128. Now I need 156, so simply subtract the 128 from the 126. So 16, 8, 8 and this is 4 to 28. 28 is left. Now 64 here there. I have to write it as 0 and 1. If I write it as 1, 64 is greater than the 128. If I add this 64 to 128, it will come greater than the 156. But I need only 28, so I will write it as simply 0. Now 32, again I can write it as simply 0. Now 16, yeah, 16 I can write. So 128, 28 minus 16, that is 4 plus 8, 12 will come. Yeah, so this is 8 2, yeah, perfect. Now the place value here it is 128 0 0 16. Now I need 12, so I can write it as 8 as a here place value. Now again 12 minus 8 4, so 1 I can write 4. Now I am done. So if I add this 128 16 8 4, I will get the 156. So I am done. I will make it as a 0 0. Now here the place values is 0 0. If I add all these place values, definitely I will get the 156 value which was we want. So that means the 156 of a decimal number can indicate in the binary number is 100 111 000. So the length of binary number is 8. Okay, so how we are getting? See, if this number is there, we can simply convert it into the 0 1 2 3 4 7 and make it as a positional values, and just add all the place values. So but 156, how can we get convert it into the binary number? It's the same thing. You have to write down your place values, but we don't know how much place values I can write. Based on the practice, you can judge that. I wrote the 8th place, but 8th place is not needed, 9th place is not needed, 8 number is not needed. So I just stop here from 7. Why? Because the 256 positional value is greater than 156. So that is why I stop 7. So that means 8th number of length is 8 digits will come. So I just simply written all the place value positional values. Now I will choose the positional values one by one based on the number. So if I add all the place values, it should become 156. So that is a simple fundamental concept. Now it is applicable to any number system. You can convert into the different number system. Now coming to the hexadecimal, we know hexadecimal means it's a 16. There is a 16 numerals or digits will there. So that is 0, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Along with 10 digits or 10 numerals, there is another 6 are there. What is that? A, B, C, D, E and F. Now what is the face value of A? You can continuation. After 9, 10 will come, 11, 12, 13, 14, 15. So that means the face value of F is 15. So what is the maximum highest number in the hexadecimal? That is the 15, that is F. So what is the unit digits? I can write it as maximum number in single digit number F. But in hexadecimal number system, 9. 9 is the highest number in the unit digits. So what is the second 2? If you make it as a 2 numbers, then 99 is the highest number in the 2 unit 2 digits number, but here it is FF because this is the highest number F. Okay, now coming to the same concept, if I take the 1 BC, for example, I want to convert it into the decimal number. What is the value of 1 BC I need? So what I will do, I will write simply 0, 1, 2, 3. So the concept will not change. So to do now base is 16. 16 power of 0 is equal to 1. 16 power of 1 is equal to 16. 16 power of 2 is equal to 256. Now I need place values. What is the place value? 256 into 1, that is 256, and 16 into what is the face value of B? Here face value of B is 11. So 11 into 16. So 110, that is 66, that is 176. And C, what is the face value of C? It is 15. 15 into 1, that is the 15. If you combine all these things, so 6, 12, 12 plus 15. Okay, C place value is face value is 12. Sorry. So you will get the 444. Now the value of a hexadecimal number 1 BC is equal to 444. That is usual notation. Simply whether you are not written or written, that means if you written is 10, okay, that is perfect, it is the decimal number system. But if you are not written, that is treated as a we are using decimal number. So 444. Now can we convert the any number into the another decimal number system? For example, if I want to make it a conversion of 198, can we convert this 198 into the hexadecimal number system? Yes, I can convert. So I know that I will write first simply 0, 1, 2, 3. So 16 power of 0 is equal to 1. 16 power of 1 is equal to 16. 16 power of 2 is equal to 256. I will stop here because 256 is greater than 198, and I don't want this 256 also. What is the least value in the hexadecimal? That is 1. If I write it as 1 here in this place 1, I will get 256 place value, but I don't need. So that means 198 of a decimal number, if you want converted into the hexadecimal, the maximum 2 numbers will come. Only it is the 2 digits will come. The length of number is only 2. Now, so this second place also we don't need, third place also. Now, so now the question is here the face value is 16. We need 198. The maximum number I can write it as F 15. So we have to check what number I have to write in this place. So 16 10 160, 16 11 now 176, 16 12 if you add 1 6 that is 2 plus 1 and 192. Okay, that is perfect because 192 is lesser than 198. So I can write 16 into 12, that is the C. Now face value is C 12. Position value is 16. 16 into 12, that is 160 plus 32, it is 192. Now our place value is 192. Now how much left? Here 6 is left. So what is the number I can write? 6. So this is the 198. So the number of 198 is in hexadecimal is C6. So the concept is same. Now we are not going to discuss the octal number system. You can try it in octa number system in the same way, but in octa number system the numerals are only 8: 0, 1, 2, 3, 4, 5, 6 and 7 only. These are the 8 digits we are using in the octal number system. You can try with the octa number system, but rarely they are not asking, they will rarely they are asking in the competitive examination. But these three are very important: hexadecimal and binary number system and decimal number system. Decimal number system is as well usual number system which are using in our daily life. Now this is your task, you have to do. So how can you convert it into the decimal number? What is the value of 11001011? Simply write it as 2 to the power of, I can write directly 2 to the power of 0 is equal to 2, 2 to the power of 0 is equal to 1, 2 to the power of 1 is equal to 2, 2 to the power of 2 4, 8, 16, 32, 64 and 128. Now I can add simply 128 plus 64. Now 0 0, so 32 0 is 32 into 0 0, 16 into 0 0, so 8 into 1 8, 4 into 0 0, 2 into 1 2 and 1 into 1 1. So if I add this, this is 10 and this is 130, 192 and 202. I think 203 will come. You can cross check it. This is 10 and this 60, it is 188, 192, 192 is 10, 202, so 203. Okay. Now you can convert your task. 6 to the power of 16 power of 0 is 1, 16 power of 1 is 16, 16 power of 2 is 256, 256 into 2, so 250, 250, 500 and 512, 512 plus C. What is the value of C? A is 10, B is 11, C is 11, C is 12, 12 into 16 we are already done 192 plus 4 into 4 4, so this number will get, so 192, so these 2, these 4, this 8 and 9 plus 1 10, 1, so 2 plus 5 it is 708. So you just tried this converted this number and you can convert this 442 in the hexadecimal number as well as binary number. If you need binary number, the length of number is more, because 2 to the power of 1 is 2 to the power of 0 is 1 2, so I want to convert it in binary number. So 2 to the power of 0 is 1 2 4 8 16 32 64 128 256 and 512. 512 is not necessary because it is greater than 442. Now can you say what is the length of number 442 in binary number? 1 2 3 4 5 6 7 8 9. 9 numbers will come. You just try it here. Can you say length of number? 512, 1024 and 2048 and 4096. So length of number here it is 9 and 10 11 12 13. So the binary number is length of number binary number is 13, here it is 10. You just try it. That is your homework. So far we learn what is the aptitude, why it is important, and types of aptitude and different number system, and we know that we are comfortable with conversion of decimal number into binary number, binary into hexadecimal and so on. Now the most of the people they are asking the question, how can I build the aptitude? Aptitude you can build only by practice. If you if you done more practice and you have the more aptitude, you have the more intelligent than others. So that is very important in the any competitive examination, and there is no shortcuts for that. You have to do continuously, you have to do more practice and more hard work. Yeah, thank you.